Okay, welcome everyone, and thank you for joining us for today's FOM. Today is my good honor and privilege to bring to you Professor Pat Reiff from Rice University. She's quite a distinguished individual. I was looking at her bio and CV earlier today, and just kind of scratching the surface here. I can tell you that in the 70s, she got her degrees, her Master's of Science and PhD from Rice University. Her PhD was in analyzing Apollo plasma data. Her interests include magnetospheric convection, plasma particle acceleration mechanisms, and solar wind control of the magnetosphere and ionosphere. She was a co-I on the Dynamic Explorer, Polar, and Image missions, and is a co-I for both the science and public outreach for the Peace Electron Spectrometer and Clustered and Education and Public Outreach lead for the MMS mission. And also the Education and Public Outreach, is on the Education and Public Outreach team for the Center for Integrated Space Weather Modeling. She has served as Director for Public Education Projects for over 22 years. Her space update software has been used by well over 1 million visitors at all over 15 museums, and together with the Earth Update and Space Weather has been distributed to 250,000 educators and learners. So these CDs, now DVDs, as her bio explains, received the highest rating from NASA review panels. Her project Immersive Earth is cooperative with the Houston Museum of Natural Science, creates a full dome digital planetarium shows for teaching Earth science, and has created a portable planetarium system called the Discovery Dome to teach Earth and space sciences through immersive digital theater, which is now in over 165 sites in 28 countries and 31 states. She has a long list of awards. Recently, the STEM Influencer Award, the Women's Energy Network, inaugural reception 2018. Also in 2018, the Marjorie Corcoran Award. 2013, Space Physics and Astronomy Richard Carrington Award. In 2012, she was named the Berkeley Distinguished Speaker for the Norwegian Academy of Science. And the list goes on. She was elected Fellow of the American Geophysical Union in 1997. She has 12 PhD students, with 2 in progress, 4 of whom are women. She's the director of the Masters of Science teaching program, which is 31 alumni as of 2020, including 18 women, and there are 4 students in progress. So like I said, I could go on, that's just scratching the surface. So again, very distinguished speaker today. And Pat, I think I will give you the floor and let you proceed.
Great. Okay, thanks. So good to be with you all, although I can't see anybody. I'm used to teaching with my students and having all their pictures showing up. So welcome everyone. And it's good to be here with you virtually. Of course, I love coming to Boulder, so I hope I can come in real person one of these days. So I'm going to talk a little bit about teaching magnetospheric physics to the public, because there's a lot of exciting ways we teach it to our graduate students, but teaching to the public is kind of a different thing. Well, my mom and dad were both MDs, and I thought I was maybe going down that path. But I loved the outdoors, so maybe I was going to be a vet. I didn't know, but I thought I knew what a plasma was. But my dad took me to a father-daughter series on astronomy at the Oklahoma City Planetarium when I was just a Brownie Scout, and I really got hooked on astronomy. It was so much fun to see the sky and try to understand it. But the thing that actually got me into space physics when I was still like 10 was a Bell Telephone Lab film that was directed by Frank Capra, the same one who did It's a Wonderful Life, called The Strange Case of the Cosmic Rays. And if you haven't seen it, it is available on YouTube. It is hilarious. But it really, the point of this movie was that science is a mystery. And, unlike some of the shows today where all the instruments are made for you, you have to create your own instruments to figure out the mysteries. And that to me was a lot of fun. So I love fixing things and I love learning things and I like to solve problems. And so that really captured my interest. It was also the first time I ever saw a magnetosphere in junior high. And, this was pretty dated. I mean, the scientists were all white men with smoked cigarettes, but it still was a lot of fun. And one of the interesting things about this movie, at the end, it says, we haven't solved the mystery yet. Come back in 50 years and we'll tell you how we did. And, I take that actually as a challenge. I think we should, as a community, redo this and say, what in fact do we know about cosmic rays in 50 years? So anyway, there's the link to the YouTube if you want to watch it. Well, so I graduated from physics and came to Rice, and I got accepted in both the physics and the space science department. And I said, well, who's got a summer job? Because I don't have anything to do my summer after college. And they said, well, we just put an experiment on the moon on Apollo 14, and they're looking for a computer program. And I said, oh man, I'm here. So if you notice the old 9 kilobyte machines with paper tape, it was fun to be in the early days of computing as well as the Apollo. And this is real-time data coming off at Johnson Space Center, and that's our instrument on the moon. And little I know, we've never been back yet. But so it's no surprise that as I've now matured and do space physics as my real job, I still want to give back to the community. And I like to do it with planetarium shows and movies, because I know they can influence people and they can change people's lives, especially people at that early age where you can still divert them from their path. Now it's a little tricky to do outreach in magnetospheric physics because we don't have the gorgeous photos that they have in astronomy, but we do what we can. Well, there are a couple of plasmas that you can see, and one of them are auroras, and there's also comet tails. And if you're really lucky, like Alan Dyer was, you can actually see both at once. I learned quickly that plasma meant something other than clear blood products. And again, that helps to bring that hook, that helps to bring people in to show them that not only we have a mystery of science, but it can also be beautiful as well. And these are, of course, NeoWise shots from this summer. And I hope everybody got a chance to go see it in real life. It was gorgeous. But we also, trek thousands of miles to go see another plasma that you can see, which is the solar corona. And there was a meme on Facebook this summer. It had, bad corona was the coronavirus, okay corona, which is the corona beer, excellent corona, which is the solar corona. So many of us go far distances to see the solar corona, and it is a very dramatic and exciting plasma that you can see. This is one I took in Chile in 2019, and I hope to be in Argentina this December, but that's going to be dependent on corona. Because nothing really can be being there in person. When you really see a total solar eclipse, it's not just a visual thing. It's a whole body thing. The temperature falls, the winds picks up, the sounds change, the birds start to roost, the shadows get really sharp, the sky gets a funny shade of gray. It's really amazing. And this is a composite photo. You can't take a single picture that captures everything you can see with your naked eye and a good pair of binoculars. But this really tried to do a good job by superimposing both short and long exposure images. Well, so my research is about convection and the aurora. This was a really exciting event that we looked at, that we had the aurora from both poles simultaneously, and it was a case with a really strong BY. And so the aurora was strongly skewed in opposite directions in the two hemispheres. And we used that skew to help determine which of the various MHD models did the best job of predicting the open-closed boundary. But these are kind of some of the things I do in real life. And now I'm working with the MMS mission and studying reconnection, both from analyzing the particle and fields data, but also from running MHD codes and comparing them to what we see in the data. This is a particularly neat animation that Paul Kasek did for me for the planetarium dome, because it can be, he really tried to see which field lines map to which other ones. This is a real simulation. And you can see for our strong BY, you get these field lines that twist as they are opened up on the day side. And when they come back together on the night side, they can cross over each other and cause very interesting reconnection in the tail, coming across the side instead of coming from the top and bottom. So you know what I study, and you know why I'm interested in it, but how do you get funded to do outreach? Outreach isn't cheap. I mean, there's a lot of things we can do relatively inexpensively, like, you know, this talk. I put it together on my desktop. But to actually get out there and reach people in bulk, you either need a good website, or you're going to have to do events or something like that, and those things cost money. And there are opportunities that come up, and you know the carousel is turning, and you have to grab where you can and hold on for dear life, because often the rules change. Even when you think you have money, you might not. So for many years, scientists who wanted to talk to the public were really looked down on by the scientific community as bombasts or self-promoters. I mean, and even, or maybe especially, Carl Sagan, although the public loved him. A lot of scientists really thought that what he did was really for himself. And so there's a lot of trying to dispel that in the community. At the time, in the 80s and 70s, 80s, and even early 90s, NASA's outreach was all from the public affairs division of NASA, and the education division did their own thing, and they were all completely separate from the science directorates. None of these people talked to each other, and they all had their own sandbox. Well, what happened that was path-breaking was around 1993. I might have been 94. I was a new member of the NASA Space Science Advisory Committee, and a young Sherry Morrow, who was working with Jeff Rosendahl at the time, made a presentation to the ESAC about getting able to link the missions more closely with the education and public outreach. I mean, it seems kind of an obvious thing to do. And I will say, the committee wasn't all that impressed to begin with. But Josh Grindley especially, and I, and a few others really started pushing this and said, look, this is the right thing to do. We need to get mission scientists involved in outreach, because they really know what the science is. They know what their instruments are telling them. If we have everything that we do is digested through public affairs, then at least 30%, often 50%, were just wrong. So as a result, we voted, and the committee was formed called the OSS Education Implementation Task Force, which I was on. And the result was we proposed a 1% tax on the mission, MONDA, to fund a new education and public outreach ecosystem so that the scientists would be involved. It was called the Broker Facilitator Program, and it was actually rolled out in 1998. It was a tremendous success with many educational products and web accessibility on these educational products. There was product review and was, I think, very, very successful. So it was canceled. And that was 2007. And for more information, you can see Sherilyn's write-up on what it was like to be a broker facilitator. And some things worked and some things didn't work. I mean, you know, we are kind of a herding cats community sometimes. So some things work better than others. But even though then that particular program stopped, the missions had some money of their own. And so each mission then went back to trying to figure out an EPO program. And for a while, each mission was required to put an EPO program in their budget and in their proposal plans. And, you know, it did a really good job of getting people out and engaged. And, you know, we even had, you know, rubber chickens. And, but that didn't last too long. And that was rescinded in 2012. And the upshot of all these things being rescinded were there was a lot of people who had started to make careers out of doing education and public outreach that suddenly found themselves all, you know, out of a job, which was really sad. And what happened, the COSTEM then took away the EPO money from these missions and put them into other agencies, NSF and education and the National Education Agency, despite the fact that it wasn't education money, it was mission money. And of course, some of us got really up in arms that our mission money was taken away. But fortunately, we had at that point developed a pretty talkative, very supportive public community, and they really went up in arms and went to the Hill and fought for NASA missions getting some of that money back. But of course, well, they couldn't just hand it back to the missions, so they had to figure out a new way of doing it. And so it was called the SciAct, the Science Activation Program. And it began in 2015, where again, this 42 million, which was about half of the money that got restored, was spread out among 24 groups, some of which were themselves consortiums, and they used these restored funds for a variety of programs. Now, in Heliospheric, we had what's called the Heliospheric Education Consortium run out of Goddard. The goals of this SciAct was to enhance STEM learning, leverage NASA assets, broadening participation, and developing networks. And again, for the last 5 years, these programs have I think, really done a tremendously admirable job. The one in heliophysics was called the Heliophysics Education Consortium, but it also included some projects that really were broader than just heliophysics, like Science Friday and like the Solar System Ambassadors and the astronomy networks. So they broadened the name to the Space Science Education Consortium, and that's what we've been doing for the last 5 years, is working together, trying to leverage assets and do projects together. And some of the things that we've been doing have been really, really spectacular. The Aurorasaurus has come out of that. Radio Jove got folded into that. We went to work together very strongly on the Eclipse 2017, getting glasses out, getting information out. So it's been a really spectacularly successful program. Well, it just got reviewed, you know, and of course, as all reviews, the reviewers have to tell you something to do different. And in fact, we are gonna, one of the things that recommended to our consortium is that we go back and narrow our focus back more to heliosphere, which of course for me is fine. I'm happy to be more narrow in heliosphere, but it's nice. It's nice to work together with people that are working in all phases of science, because none of us are alone. When you look at a Jupiter mission, as Frank could tell you, you've got plasma physicists, and you got people who look at moons, and people who look at atmospheres, and people who look at cameras. And so having too narrow a focus, I think, can be not as effective. Well, so I've been lucky that each major competition that's come out and that we won created a lasting program, which is really, really nice. And so a lot of the things that I started in the 80s actually are still operating today, and a slightly revised format, but it's still going along. For example, my very first teacher research program in 1988, we gave teachers academic credit, and they had to do a research project over the summer and write a science paper on it, but also write a curriculum product with it. And that one we did a follow-on with the Eisenhower Foundation for the fourth year, and it basically led to the Master of Science teaching program at Rice, which I'm the director of. And as he mentioned, we have 31 alumni so far, and 5 of them have gone on to get PhDs in education. So that's the website for that. The next missions, that was really the only big one I did through NSF. The rest of them I've done through NASA. The first cooperative agreement that we did was called, we called it Creating the Public Connection, and it was under the aegis of the Public Use of the Internet program. And it created our software Space Update and Space Weather. In 1998, there was the Earth Science Information Partnerships, and we put in a proposal for a cooperative agreement there on museums teaching planet Earth, and that's when we updated our planetarium in Houston to full digital and created the first digital Earth Science Planetarium show, and others. In 2004, we had a follow-on called Immersive Earth, and again, creating more Earth Science planetarium shows, and created the Portable Discovery Dome. In 2010, we had 2 more planetarium shows through the CP4 SMP program. And all of these shows that we've created and the dome that we've created, because there were cooperative agreements, we could choose or not to go commercial, and people wanting to buy it, so we decided to do the commercial spin-off. And the university has been really good about releasing all the intellectual property to our e-planetarium company for distribution of these shows. So just a little more detail, our Creating the Public Connection one created our software suite Space Update. The very first software suite we had online was Comet Shoemaker-Levy 9. We had a kiosk in the museum with pictures of Comet Shoemaker-Levy 9 within 6 weeks after the encounter, and we were very, very pleased about that. And all the new ones now are fully internet accessible, so they can bring down new data. They can be updated remotely. And our Space Update suite contains astronomy, sky to night, solar system, and space weather modules. And they're still in distribution. Interestingly, other winners of that first competition were Windows of the Universe. Many of you know Roberta, and another one was the Internet over Cable TV, which was a pilot project, and of course now is in many people's homes. And the last one was Stanford was one of the winners with their project, which has led to Google. So, I think NASA did a really good investment at that time, trying to put money into innovative projects and products that could bring NASA resources to the public easily. Well, so Space Update is still, as I said, still viable, but it has the space weather section you can also get separately. And because of MMS, you can actually get it free. If you go to the mms.rice.edu website, you can download the Mac or the Windows download the installers of the space weather software. And what's fun about that is it has real-time solar images and real-time space weather forecasts. And everything was is actually created so they can run on a touchscreen kiosk. So that's why a lot of it is not as like you think a more normal, newer software is. This was designed to be a captive program to run in a kiosk. And basically, our software has been running at the Houston Museum of Natural Science since 1995, which is now closing in on 25 years. We've had a kiosk at the Houston Museum of Natural Science and at other places. So if you go to space weather and you click on the sun today, you can see what the sun looks like in different wavelengths, and you can update the single image, or you can tell it to update everything. So I updated this not long ago, and you know, we've had a really dry spell with almost no sunspots, but here's a nice little sunspot. And if you click the buttons, you can see the inner corona in different wavelengths, but then you can also see it in magnetic fields, and you can see the with the magnetic fields, you can see the in and out magnetic fields associated with that same sunspot. So having the whole suite update at the same time, you really get a right now picture of the sun and all the different wavelengths. It also has real-time space weather forecasts. So we have a neural network, and we use the Discover data to predict 1 and 3 hours ahead what the KP index is, and the DST and the AE, and we do decent well. Since it went from ACE to Discover, though, there's some the cross calibration between ACE and Discover is not perfect. So really, we need to go back and retrain our neural network using the Discover data instead of the ACE data. So it's not as accurate a forecast as it used to be, but it still does pretty good. And we've been sending out a lot of alerts over the last day. Another interesting thing to see is the coronal imager from SDO. You can see these, coronal mass ejections happening when the sun is active. But what's interesting right now, if you look at at those movies, you can see the galactic cosmic rays hitting the detector. And you really can tell that when you're at a deep solar minimum like we are now, there's a lot more galactic cosmic rays getting into the inner magnetosphere than at times of solar maximum. So we also post the space weather forecasts also on the MMS website, so you can pull up these forecasts. And if you want to, you can sign up for our SPAC alert forecast, especially if you live in, the northern tier states or Alaska or Europe. We'll send out alerts whenever the KP and our predicted KP index goes above 4. We'll send out an alert. Another thing we do nearly every year is Reach for the Stars STEM Festival. We bring in middle school girls. We have them for a full day. They start off with a street fair where they get to play with all sorts of fun hands-on things. And then there's an astronaut speech with a lunch. And then they go to hands-on workshops led by women, scientists, engineers, mathematicians, or medical doctors, and very, very popular. We had to postpone our one that we were going to have this fall. Hopefully we'll be able to do it in the spring. One fun thing is we got a
I'm Peggy Whitson, Commander
message from Space Station.
International Space Station. I wanted to take a moment to congratulate all of you participating in the Science Festival underway at Rice University. I know this is an exciting opportunity for you that is filled with learning and discovery. You are the scientists, engineers, and astronauts of the future. So do as I did. Stay focused on the future and study hard. We will need all of you and all of your talents to help in our exploration efforts both here on Earth and in space. Enjoy every minute and have a great day.
So, of course, we're very excited at Rice to have one of our alums going up on Crew 1, Shannon Walker. So we're hoping that we'll get a new one from Shannon for this year. This is why we didn't do it this year, as the street fair, and it was all in the academic quad, and not socially distant. So we're going to have to do some slight adjustments to make it work for this year. The class I'm teaching this semester, and I teach it every other year, is called The Physics of Ham Radio. And it's a really fun class to teach. It teaches the fundamentals of electromagnetic waves, wave propagation, antennas, electronics, the sun and the ionosphere, and space weather. The midterm exam is actually the technician license exam. So they're required to take the technician exam. They're not required to pass it, but most of them do. So that's sort of the first half of the class, is getting basic electronics, doing basic electronics labs. And then the second half is more space weather and the sun, and they do homework on the solar wind, and they learn how to use a GPS and how it works. And so it's really a lot of fun, and the kids really enjoy talking around the world. We talked to California the other day. We were listening to New Zealand, but we couldn't get through the pileup. and they end up with their ham licenses at the end of the day, and that's a lot of fun for them. Another thing we do is we create planetarium shows, and many of them were sponsored by the Earth Science division of NASA, but some of them, like Force 5, was funded 2/3 by Earth Science and 1/3 by Image. So we called it Force 5 for the things that are level 5 storms. So it has a section on hurricanes, a section on tornadoes, and a section on space storms. We actually made each section separate, so you could just show the space storm show if you want, and it's not very long, it's less than 10 minutes. So the original version was done in 2001, but we updated it in 2010 with some more information from MMS. And all of our shows you can watch on our YouTube channel, ePlanetarium. And it's been one of our most popular shows, especially hurricane season around here. Our more recent show is called Magnetism, it actually comes with 2 different titles: Magnetisms or Arcs to Auroras, because some places the Aurora name pulls in more people. But it talks about the basics of magnetism, solar storm CMEs, reconnection, and it also can be watched on YouTube. And we talk about how the magnetic field protects us from galactic radiation, and also how solar storms might lead to electric blackouts. We talk about magnetic field reversals. And that's really hard in a 23-minute show to go into a lot of detail on anything. But the idea is to kind of get people the flavor and the words and get them excited about it. And these shows are really designed to be immersive. You're really in the action, and it's not just watching a TV screen. You're all around you. And one of the studies that we did was on retention. We played a planetarium show in a dome for a group of middle school kids in Houston, and half of them saw it in the dome and half of them saw it on the flat screen. We did a pre and post test immediately before and immediately after the show, and both groups learned. I mean, it was good stuff. It was the same soundtrack and the same visuals for both. But what happened was we came back 6 weeks later and we tested them again. And the ones that had watched it in a dome retained virtually all of their gain, whereas the ones that had watched it on a flat screen had lost most of their gain. They'd forgotten what they just listened to. So the fact that you're in a dome, you've got kinetic learners, you got auditory learners, you're creating an experience for someone instead of just one more movie. And so now we are actually up over 350 of our portable domes in the field, and we're over 55 countries and 45 states. So we're really happy to be out there. So our portable dome, you know, you can set it up just about anywhere where you can get electricity or a generator. Now, this was a previous president, I will tell you. But we go to the astronomy night on the National Mall every year, and that's a lot of fun. And in fact, one year it was raining and everyone was still coming in and out of the dome. But we take it to schools around the world and to public events, and we have a lot of fun reaching people with our shows on space physics. This January, right before everything shut down, we went to South Texas and went to 4 schools that were primarily Hispanic and reached almost 3,000 kids in 4 days. Every year we go to San Antonio. This is set up in Southwest Research, and the students that are there for their summer program come to the dome, and this is Roman Gomez, many of you know. He brought over some of his students, and they got to see the magnetism show in the portable dome. So it's really fun. You can go anywhere, and you know, I've taken it on cruise ships and to all around the world. Well, another thing that we've been doing under the aegis of the Heliospheric Education Consortium was eclipse information and animations, particularly created before the 2017 event. So we have, you know, a full set of frequently asked questions on what's a lunar versus a solar eclipse, what's an annular versus a total. And if you go to space.rice.edu, you can download all of that information, and including a bunch of safety information and how to build eclipse viewers. So we did 7 full dome animations on eclipses, and all of these can be downloaded either in fisheye format for domes or in flat screens. So like this is, oh, now why did you just die? Okay, well, I'm not quite sure why that decided it didn't want to run, but that's if you go to this eclipse animations, we have a number of them. I guess I can I can show it now. I may need to resave this. Hang on. I'll probably have to reshare the screen. So here's my eclipse page with the lunar and solar eclipse frequently asked questions and the chart. This was the one that went through India. I'm going to be updating it really soon with the newer ones and the eclipse training and all the eclipse animations. Then you can see one on what's the general eclipse geometry, what are Bailey's beads, what does a solar eclipse look like from Earth orbit, what does a solar eclipse look like from the moon and as it gets red. So all of these are animations that you can download and watch in various, and they're all relatively short, just a few minutes long, so you can embed them in
as the moon covers the last bit of the sun, the sky around you gets dark. It's still not safe to remove your solar filters, though. The last piece of the sun makes a diamond ring. Bailey's beads appear, small bits of the sun peeking through valleys on the edge of the moon. Now it's safe.
So anyway, that's one of the short ones. All right, I'm going to go back to the PowerPoint. Oops.
When the new moon
now it's going from the PowerPoint, of course. Can you all see this, or do I need to reshare?
Right now, we just see your video feed. We don't see the slides.
Okay, I better start over sharing. Okay, so
when the new moon passes exactly in front of the sun, its shadow crosses the earth. The deepest part of the shadow is called the umbra. People in the umbra see a total solar eclipse. It takes about an hour for the shadow to cross the earth. 2 weeks later, the full moon can cross into Earth's umbra. Since the earth is 4 times the diameter of the moon, the umbra is also 4 times larger, or 16 times the area. So, lunar eclipses are more common than solar eclipses. Everyone on the night side of Earth can see a total lunar eclipse, but only people in the narrow strip of totality can see a total solar eclipse. So, not only are lunar eclipses more common, more people can observe each one.
Okay, so we give people the script so they don't have to listen to my voice. So going to eclipses, I have a tendency to take fisheye images so that I can put them in the dome. And so like this was one from Ternate, and we were pretty nervous about the clouds, but they do have, the high cirrus do have a tendency to thin out right before totality, which is nice. And some of the really most gorgeous pictures I've ever taken are all of diamond rings near eclipses, and some of these really spectacular rainbow features are really amazing. This is a wonderful diamond ring from Tahiti. The other thing that we do is we work with predictive science, and they will give us a prediction for what the eclipse should look like based on the three-dimensional magnetic field reconstruction of the sun. So they'll usually give me a prediction of the eclipse, you know, a few days before. And now we're going between, this is a video between their prediction in blue and what we actually saw in gray. And it's pretty impressive, actually, how well they can do to predict, you know, what the overall structure of the eclipse will be like just from the magnetic fields of the sun. And of course, the exquisite detail of eclipses is really makes you believe in the magnetic fields that are emanating from the sun, because you can see them. Which I think is one of the most exciting things, is to be able to really see magnetic fields. So in July 2017, there was a huge NASA push, and literally millions of people in the United States saw total eclipse. This was where I was in Wyoming, and I love, with the fisheye, you can really see that it makes a sunset all the way around the horizon. But it's coming. So there's 2 more coming soon. There is an annular coming on October 14th of 2023, and it is going to hit some of Colorado, you guys, so you don't have to go very far to pick up the annular. Now, you know, an annular is not as much fun as a total because you don't get to see the corona, but it's still a very fascinating thing. And you can see Bailey's beads at the beginning and the end of totality of the annularity time. So this is the cross of the country that we'll have for the 2023 annular. And if you've never used xjubier.free.france, he has Google Maps for all the upcoming eclipses. You can click on it. It'll tell you exactly the start and stop times and what fraction of the sky of the sun will be occluded. It's a really wonderful resource. And if you use it, donate. But here's the next big one that's coming over the United States. So everybody's getting excited now, and so it's not too soon to be thinking about where you want to go. You have to pay attention to both how far you have to drive and what the weather is going to be like. There are some people in Southern Illinois who got to be right at the intersection of both eclipses, so they'll get to see it twice from the same spot. But it's going through Dallas, which means there's a fair number of people that are going to be able to see it. It's also going even through northern Maine, but I worry a bit about the weather. So it's April 8th of 2024. So again, make your plans. When I picked the spot to watch in 2017 in this dude ranch, which in Wyoming, that was right on the center line, I called them up like 3 years in advance. And I said, I want all of your cabins and, 3 RV sites and 5 campsites and, for 2017. And they said, lady, we don't accept reservations more than a year in advance. I said, yes, you will. Let me tell you why. They said, well, I don't know what the price is going to be. I said, I don't care. I will pay your standard 2017 price. I just don't want to pay 5 times your standard 2017 price. And I promise you, I'll give a lecture to everybody that you have. And it turned out great. So, plan ahead and find your spot. So that's it. And I'll be happy to answer any questions. And so glad to be here with you.
Great, very nice talk, Pat. That was very cool. A lot of interesting things there. And I was thinking I'm gonna have to go back and just watch the recording just to get a lot of those URLs and links and whatnot. Questions.
So Pat, hi, Steve Schwartz here. Great talk. I think one of the things that people should take away from this is that in order to do good public outreach, you need to be very creative and very energetic and somehow manage to find the extra 5 hours in every day in order to get it done. I'm sure that's part of it, but I think it's also great that you've made people aware of the resources that you've got there at Rice. I know, rather than kind of everybody scratching their heads and starting from scratch, they should not only learn from the people who have done it before, but also, beg, borrow, or steal what they can. I must confess your opening remark about the film Mr. Sun, caught my attention. I guess you're at least old enough as I am to remember it very vividly. And the one thing that I want to underline in what you said about it, because it's the one thing that likewise sticks in my head, is that right at the end of it, there is this question that's posed, and we don't know the answer yet. And I think that's really, really important. It's a really, really, big hook into somebody who's got that curiosity. It's what distinguishes science from kind of, everything else, is that we don't know the answer yet, but we're going to do our damnedest to find out. And it just sets that curiosity going. So there's no question in that, but great talk.
Well, many of you know my husband, Tom Hill, who's a space scientist himself. And I will say that part of my being able to do what I could do is having a husband who's also in the field. And, when I abandoned him with the children for 3 days, of course, he gets grumpy sometimes and said, being married to you, it's sometimes like being a single parent. But it's been great. Yes, France.
I'm curious about how you see things moving forward with funding of EPO efforts at NASA, and how do we go back to that era when we required missions to do a whole bunch of EPO? Because I thought that that was great. We had in New Horizons was at the peak of that, and indeed that paid off enormously. Similarly, Juno, I think, got started when it was just before it faded. And of course, the citizen science camera on Juno has been fantastic, and so on. So, but it's frustrating when really we want to do some EPO and get some stuff set up, and there's no money for it. So in the current era, for example, there's a big fuss about EDI and how do we expand the diversity of, and you can't just go, the problem is the pipeline. You can't just go out and hire a cluster of Afro-Americans to be faculty. We've got to deal with a bridging program to the local high schools and local middle schools. How do we get funding to bring them in and do a summer school and do internships and teacher training and all the things that we need to do to get that going? And there's no money for it.
And we set aside the money for it. I mean,
Yeah.
It was not that big. I mean, 1% of the data analysis and MO&DA is not a huge tax. And the missions were happy to do it because they saw the payoff. But one thing that's really, really important, especially if you're working on the pipeline, is a program that's continuous. You know, we've been doing this Reach for the Stars now since 2006. And I've now, when there was we hosted the undergraduate women in physics symposium, and I had a girl there who had been to Rice as a as a middle schooler, you know, but you have to have something that's long-term enough to pull them through, and also to be able to prove that it was successful. And one of the complaints that they did on our renewal proposal was that it leans too hard on satisfaction surveys and not on long-term. Well, you know, how much long-term can you do in 5 years, you know?
Right.
So
Yeah.
it's very frustrating.
So is the problem because the Department of Education got jealous of all the attention and stuff that we were getting at NASA? And so they sort of muscled in and said, we're the education experts. Yeah, that's what I thought. And so maybe we just need to use a different word, right? Often you have to, it's not education and public outreach, it's communication or community involvement or citizen science, or we have to change the phrase.
Yeah, I think citizen science is a niche that we can really exploit.
Right.
Okay, and one of the things that, again, we got guidance for the next 5 years is to be more in education and not just in public outreach. And yet, you know, if you don't throw a wide net, you know, you never know who you're missing. And I can tell you, it works. It worked in my life, and I can point to, you know, a handful of other people. Rice University, for a long time, had a grant to help diverse graduate students get through their first few years, and it was the Hispanics and the Blacks and the Native Americans, and they had, you know, parties, and they had support groups. And at one point, because of Tapia's program, half of the PhDs in color in computer science were from Rice University. In the entire country. We graduated half of them. You know, and guess what? You know, you got to keep doing it. You can't.
Yeah, so I think we have to go to CSSP and to other NASA advisory systems, and certainly I'm involved in the decadal survey. It's not for planetary science. It's not a secret anymore. It came out the past couple of days, and I will certainly be active in trying to get this back into NASA missions. Yeah. Thank you very much. Lovely talk.
it's a lot of fun, but I tell you what, there are many nights that I have the nightmare that I've got the 12 sticks and the plates on 12 sticks, and I've got to give each one of them a little kick to keep all those plates in the air, because it's hard to do both and be a mommy. I figured at one point I had 6 half-time jobs, including being a mother. Yes, Robin.
Right. Thanks, Patricia. Thanks for a nice talk. I just came to think about when you were talking about the planetarium domes and how it helps with retention. I've heard the same thing said about, say, science on a sphere, where you project, say, the features on a planet on a spherical display, that the students retain a lot more knowledge. But I'm trying to understand what it is about this kind of experience that really makes the information stick in a different way, and if we can translate that into other circumstances like lectures or well, just TV shows, I guess.
Well, it really goes back into inquiry too. I mean, it's been shown that if you do something with inquiry based, it's part of their experience. You haven't just told them what's going to happen. They've done it. Okay. And what we find is the questions that stick the most in a planetarium are, guess what? 3-dimensional concepts. So 3-dimensional concepts are better understood in a 3-dimensional location. And so like when we do that lunar and solar eclipse, I showed you the flat screen version, but in the dome, it's actually behind you and above you, and you can really see that alignment, you know? So having that 3-dimensional space allows them to experience the 3-dimensional concept. So when you do even a star field on the dome, you do stellarium on the dome and you show them how the star fields work. Then when they go back and do the homework problem using stellarium on their flat screen, at least they know what it's supposed to represent, what that circle of the horizon really means, you know, that means that is that way and that's that way, you know. So I think that's the 3-dimensionality. But there are also people who are kinetic learners, that they really have to move in order to learn. And I think just the act of, you know, of turning your head. And people say, well, you could do the same thing with VR glasses. But the problem with VR glasses is you only have a 110-degree field of view. So you have no peripheral vision. In order to see peripheral, you have to turn your head. Whereas in a dome, you can actually get the action to come around the side or from over the top, and you really get them, you know, there's an element of surprise that something's coming at them from a different direction that they're not used to when they've been staring at a flat screen their whole lives. So I think that element of surprise, the element of being in an isolated space, you are now in a room, dark, you know, separated from everybody else. But I'll tell you the funny, I mean, the middle schoolers and the elementary are the ones who love it the most. But the high schoolers, it's fun to be with the high schoolers because occasionally they'll come in the dome and they're going, oh, I am too cool for this, you know, and they'll start listening to the show, and they've got their phones, you know, and they're, you know, tweeting or something. And then they start listening and they start watching, and then they turn their phones around and they're filming the whole thing. I thought, okay, I got you. So I think it's all of those things, just different.
We'll get them to interact. Sounds like that's the.
And the cool thing is, you can now buy a VR 360 camera for $300. You can take that VR 360 film that you can shoot yourself on a $300 camera, put it in a dome, and now you have a 360 home movie that you can show to your buddies. Now that is cool.
Very cool. Other questions or comments for the speaker? Yeah, I just wanted to, you know, make a comment. I thought this was, you know, a really great talk. I learned a lot of stuff. Like I said, I have to go back and, take a look at a lot of the information and the links that were in here. And I thought that was a really excellent point that you and Fran were talking about with the, if we, we all kind of acknowledge that we need to take seriously this problem of the lack of minorities in STEM, but, you have to reach out to those communities and get them interested, and, people in general interested at a young age, and keep that interest going. It's kind of, it's got to be frustrating, because it seems like that's kind of an easy sell to say, hey, we need money to do this. It's a very important thing. And yet, you run into various problems. So, hopefully, the community will be able to kind of get those funds going again for these various, whether you call it education, public outreach, or something else, so hopefully that'll.
Well, one of the things we did this summer is we had a series of free planetarium shows. It was flat screen on Zoom, and it was free, but you could make a donation if you wanted to. We had the movies every Wednesday, and we had the star parties on Thursdays every week, and then we also did a live the Mars launch, and we did the live of the SpaceX launch live. And with those events that we did this summer, we ended up having like 2,400 people come to our various events. But what was interesting and a little depressing is there was still, 90% white. Whereas if I take a planetarium dome and set it up, in downtown DC or downtown Houston at a fair or event, then I get what the cross-section of people in the whole city are, which in Houston is, less than, less than 50% white. And in fact, in our school district, it's only 10% white. So that's another reason why these events are important. It again gets people interested that wouldn't be listening or on the right list server to know about an online event, but a festival that's bringing Hispanic music, and you set up a dome, or one that's a Cinco de Mayo or a Juneteenth celebration, you set up a dome, and you're going to be completely full the whole time because it's new and it's fun.
Yeah, no, it definitely sounds like a very powerful tool to reach out to communities that are typically kind of overlooked, or don't traditionally have a strong presence in STEM, just because of the way things are. I don't know if it's the way things are structured, and in the conventional ways of communicating that, like you said, just isn't it making it to those communities? So it's a very good way to, very, very cool. Are there any other final questions or comments? Okay. While seeing none, I'm going to invite people to unmute so we can give Pat a round of applause.
Thank you.
Thank you again, Pat. Again, very cool talk. Very glad you could come and present this to us, and thanks a lot.
All right. Thank you.
Okay. Thanks, everyone. Bye-bye.